So, I want you to stop and think about how I'm doing this right now. Well, obviously I'm doing this because I love music and I love science and I love doing them both at the same time together. But, how can I play and how can you hear it? That's the question that we're going to be going over today in Crash Course Biology with Frank and Stein. But one of the other questions is, how am I going to do this at the same time without falling on my face? Well,
sounds create vibrations in the air that beat against the eardrum, which pushes a series of ear bones moving internal fluid against a membrane. And this triggers tiny hair cells, stimulating neurons, which eventually sends action potentials to the brain, and they are interpreted as sound. When I talk, those vibrations cause air particles to vibrate, which causes sound waves to carry the vibration through the air. So, differently vibrating objects produce differently shaped sound waves. Your ear is divided into 3 sections: the external, middle, and inner ear. The pinna catches sound waves and passes them along deeper into the middle ear. So eventually, the sound wave hits the eardrum, also known as the tympanic membrane, pushing it back and forth, back and forth. Those vibrations cause the tiny bones in the middle ear to jiggle. These bones are located in the tympanic cavity, which amplifies sound waves so they are stronger when they enter the inner ear. The reason for this is so that sound can travel well through fluid. The inner ear, also known as the labyrinth, has 2 functions. 1, to turn the physical vibrations into electrical impulses so the brain can interpret them as sound, and 2, help maintain your equilibrium, which is also known as your balance. So when you're walking, you don't fall flat on your face. Just saying. Just saying. The labyrinth is broken into 2 main parts: the bony labyrinth and the membranous labyrinth, which is a series of sacs and ducts inside the bony labyrinth. Now, the hearing function of the labyrinth is contained in the cochlea, which is shaped like a snail shell.
the most important one is the basilar membrane, a stiff band of tissue that runs between the scala media and the scala tympani. Also, right on top of it is a long fixture that is riddled with sensory and nerve cells called the organ of Corti. This organ is riddled with so-called hair cells, and when one is triggered, eventually electronic impulses travel from the organ of Corti to the cochlear nerve, then up to the auditory pathway to the cerebral cortex. Alright. So, when your cute little ossicle bones start sending pressure waves up the inner fluid, they cause certain sections of the basilar membrane to vibrate back and forth. This membrane is covered in more than 20,000 fibers, and the longer they are, the farther down they go. It's like a harp or a guitar with many strings. The fibers near the base of the cochlea are short and stiff, while those at the end are longer and looser. Also, the fibers resonate at different frequencies. So, different parts of the membrane vibrate depending on the pitch of the sound coming through. The part of the membrane with the short fibers vibrates in response to high frequency pressure. And the long fibers vibrate in response to lower frequency waves. So if you were to have a shorter frequency, it'd be kind of like this. If it were to be a lower frequency, it'd be kind of like this. Now, this is a cool thing to know. The brain can detect the pitch of the sound solely on the location of the hair cells that are being triggered. So louder sounds are the more hair cells that are being triggered, and the lower sound is the lower hair cells that are being triggered. So, the cerebral cortex interprets those signals and also plugs them into stored memories and experiences. So you can say, oh, that's Marcus talking about Ronald Reagan again, or Danielle making you all feel bad by knowing way too much about Paradise Lost in a super short period of time, or, whatever it is. Let's talk about equilibrium. This is the way that we maintain our balance, and it's all thanks to the vestibular apparatus, which is also located in the labyrinth. It's a series of sacs and canals. This setup also uses a combination of fluid and sensory hair cells, but this time, the fluid is controlled not by sound waves, but by the movement of your head. The most interesting parts of this structure are in the 3 semicircle canals, which are all located in the sagittal frontal and the transversal planes. Each canal can detect a different type of head rotation, like up and down, or side to side, and woo. There are hair cells and sac-like structures that sense the motion of the fluid that are in it. So, these cells can give the brain information on how fast the head jumps to the beat. All right, hey guys, thank you guys so much for joining us on another crash course with Dr. Frank and Professor Stein here. Together we make Frankenstein. Haha, hysterical. Anyway, Professor Stein taught you all about
the ear and how it works.
While me, Professor Frank, talked about equilibrium and how it makes us stand up, spin around, and all the other great stuff in life. And also, that's pretty much it. But we all know just why God gave us ears.
I feel like the world is like moving and being like these glasses. I feel like it's gonna fall in. I was just really telling you like the stickers apparatus.
Let's put it in motion. I'ma give you a promotion. I'll make it feel like a vacate, turn the bed into an ocean. We don't need nobody.
Alright, and guys, if you did like this video, please make sure to give it a big thumbs up and comment down below what other videos you'd like to see. And also, if you want to see more videos like this, make sure to hit that big old red subscribe button to see more videos from Frank and Stein. Peace out.
Woo!
Yeah.
Peace, 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 peace.
Peace and love, brothers.
Peace, 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 peace and love, peace and love, peace and
Peace and
Oh, did you
love,
forget-
peace
oh.
and love, peace and love, peace and love, oh
peace
yeah.
and love.
I feel swag.
Peace and love.
Josie's swag.
Leah.
Cochlea.
Leah. Cochlea.
Okay. Alright. This organ is riddled with... One more time. I'm so sorry.
Nice.
So, when your cute little ossicle bones start sending pressure waves up the inner fluid, they cause certain sensations of basilar membrane to vibrate back and forth. Oh, different sections. No sensations. I'm sorry. Alright. Now, this is a cool thing to know. The brain can detect the pitch of sound solely on the location of the hair cells that are being triggered. So, louder sounds... Louder sounds... everyone. I want some Kentucky Fried Chicken. Well, let's try that one more time, sweet honey child, shan't we? All right.
Oh, okay, so, it says stored memories.
Okay.
And Marcus and whatever. Okay,
Okay.
this is the one that you can choose whatever you want.
Okay. Okay. Now, let's talk about equilibrium. This is the way that we maintain our balance, and it's all thanks to the vestibular apparatus, also located in the labyrinth, which looks like it's a straight out of an... Oh my god. Sorry. Now let's talk about equilibrium. The way that we maintain our balance, and all thanks to the inner vibrator.
What does it say? And then vibrated to the stimulator. Okay. I guess you can name that the inner vibrator.
I'm not gonna call it that, Josie. I am not gonna call it that.
Okay.
Woo! What does that say? The vestibular.
Yes, your favorite word, the vestibular apparatus.
The vestibular apparatus.
The
I should say that like a
vestibular
British
apparatus.
person. The
Also with
vestibular apparatus. And it kind of looks like it's straight out of an alien movie. It's a series of sacs and canals, which... Oh, I'm sorry, I can't read that.
Oh,
that sets up...
this sets up... Okay, this sets up also... Oh, this setup, comma, also uses...
Okay. I was like, this setup also... What?
Setup also uses... Oh my goodness.
Alright. So canals. This setup also uses a combination of fluid and sensory hair cells. Okay. Isn't she lovely? Isn't she wonderful? Oh. You know, I'm actually a huge Stevie Wonder fan, so I hope this wasn't offensive to him. I mean, well, he's not gonna see this anyway, but... This organ is riddled with so-called hair cells, which triggered eventually... I'm a failure at life. I just want to... Literally, Josie did this and, like, was absolutely flawless.
No, it's a...
And then I try to talk, and I'm like, hey, English doesn't happen. Oh, man, I am so very sorry.
It's okay.
This organ is riddled with so-called hair cells, and when one is triggered, eventually electronic impulses travel from the organ of Corti to the cochlear nerve, then up to the auditory pathway to the cerebral cortex.
Again. Okay, you can read that.
I can't. I just...
Yeah, that was funny. The organ of Corti, the cochlear. Yeah.
Cochlea.
Like cochlear.
The cochlear.
Yeah, cochlear.
Okay. That's fine. I can cut it right there. Sorry.
Bye.
Bye. Okay, now we're gonna do...
Uniform.
and then it's gonna be like, but we really... we really...
I really